Good morning, everyone. Last time, could you please open the camera and let me know you're here? This is our common practice. Let me see here. Okay, so before open the camera, let me know here. For the time being, I would like to check the attendance. Just wait for me for 5 minutes. Now, I would like to ask you the questions about the fountain experiment. So please get yourself prepared, and I would like to ask you questions about this fountain experiment. Okay, please do so. As a before turning on the camera, let me know you're here. 黃子軒，洪尚文。
喺度啊，傻一陣間，我依家唔係幾方便。
好。 All right. Now, before we start the lesson, some clarification on those MCs, right? Somebody may find it difficult to get to know what that is. Indeed, I have I've extracted the 118 MC questions from 2 publishers. So you may find such, and what you need to do is to find out is to trace back those items, okay, by ranking it from number 1 to number 20. So yesterday my work is to check for the first 20 MCs. Your understanding on this, okay? Is that clear? So this is what I would like to draw attention to it. And any questions so far? So for today, you will be doing the 21st questions until 40. Okay, your answer should be put on the Google form while your work on doing your work. Okay, on the either on the piece of paper, right? You're going to do so and post it on your Google Classroom as well. So by doing so, it is a complete homework. Any questions? Okay, my questions, the fountain experiments. Yeah. My question on fountain experiment, could you please explain why the fountain experiments would happen? Have you ever read through that experiment, fountain experiment?
Yes, sir.
It's time to watch. I just asked you. But 3 minutes ago, I asked you guys that I will ask that question. Okay, please read through that. And Chen Yunzhong, fountain experiment. So what is it? Fountain experiment. No idea. Fountain experiment. So I would like to mark it as fountain experiment. Fountain experiment. So you may see that. Okay, a very short one.
We're in the demo lab where Lonnie's prepared to demonstrate the solubility of ammonia gas in water. This flask that he's opening is full of ammonia gas, and he'll put it on the apparatus and seal it. Now what he's going to do is introduce just a few drops of water into that flask. And since the Henry's law constant for ammonia dissolving in water is over 10,000, ammonia will rapidly dissolve in that small amount of water. What's happening now is the ammonia pressure is decreasing rapidly as it dissolves in the liquid. That lowering of pressure allows the atmospheric pressure to force the water from the lower flask up into the upper flask in the form of a fountain. In fact, it's a dramatic representation of the free energy released in this chemical reaction, as the free energy release can lift about 1 kilogram of water almost 1 meter high from the lower flask to the upper flask of the fountain.
Now, it seems that this one is rather strange because it doesn't agree with our understanding of the gravity of water. Water will generally flow downward because of gravity of the earth, right? So why is it like that? So why we have just a fountain?
咪大氣壓力啊關。
Could you please a little bit more?
好似兩邊壓力唔 balance 之後吸咗佢上去。
Why we have got an imbalance of the pressure?
ammonia 用咗喺水度。
Yes, that's right. Ammonia dissolved in water. So what will happen? So it will experience. Yes, they experience a drop of pressure, and because of the imbalance of pressure inside and outside, to balance it. So what will happen is that the water will pulled right from the trough into the glass cylinder. So it is exactly the example on page 23. Take a look on that, page 23. So this is our experimental result. So why you have a fountain here? Because the ammonia is highly water soluble. So what will happen? It will the ammonia will rapidly dissolve into the water, just like, okay, it will experience a drop of pressure. First of all, dissolve in water. Second, it will drop in the gas pressure inside. And because it is smaller than the atmospheric pressure, so what will happen? The water will then be driven. Okay, water it will be sucked up. Okay, and produces a fountain. Why is it say that it's a fountain? It's because of the rapidly release of pressure, okay, into different directions. So this is what we call it as a fountain experiment. And what's next? If you were given with some indicator solution, it will give you different color. Now, for example, if you use universal indicator solution, it will give you the solution from green to blue. Why? Why? Ammonia is alkaline, while the ammonia gas is also gas, as well as AQ is also alkaline. So this is our core concepts of the fountain experiment. Of course, if you don't use ammonia, you may use some other highly soluble gas, and you can also perform the similar experiments. For example, HCl. So later on, while you type fountain experiment into the YouTube, okay, so you cut off something of what gas. So you are going to check, and ammonia is a very authentic example because ammonia is highly water soluble. But of course, you would find some other examples, just like HCl, etc. Any questions so far? Now, this is what we will just leave you last lesson. Okay, so today what you're going to do is to referring as a very warm up, and you talk about something more about characteristics of dilute solution of alkaline. So in our daily life, you may see all those, they are just household or maybe anti-acid, okay, or the acid or which is used to reduce the acidity of soil, right? All those, they are just our daily users. How about in a lab? In our lab, we have got the following alkaline, namely KOH and NaOH. Okay, these two, they are used very similar because they are just group 1 hydroxide. While the chemical property of them, they are more or less the same. The difference is on the metal cation. Now, how about calcium hydroxide? Calcium hydroxide, it is somewhat sometimes you may find it as milky. It's because the lime water is just slightly water soluble. But of course, it's not just the reason. It's not just the reason. It's because of the gradual formation of calcium carbonate, but when it meets with atmospheric carbon dioxide. Okay, so that's why As for you will see some old stock of lime water is cloudy. Okay, it's because the CO2 in air, they will react with calcium hydroxide to form calcium carbonate, which is in terms of a white solid, insoluble in water. Okay, so you may see some lime water being milky. That may be because of the fact that there are some calcium carbonates. Okay, of course, during the making of the lime water, we will spray excess calcium hydroxide into water, into distilled water to make it saturated, and then filter off the calcium hydroxide on the soft solid, and you form lime water. But that lime water, while we stay for long, it will turn cloudy. Now, but not be found in these two. No such. There will be no cloudiness. Now, why? Because all group 1 compound, they are water soluble. Now, there's one more alkaline in which it contains no metal part, which is ammonia, aqueous ammonia. The making of aqueous ammonia is by dissolving ammonia gas into water, and because of the fact that it's highly water soluble, you may find when producing aqueous ammonia, we need to use this method. Okay, by bubbling the gas through the inverted filter funnel. By doing so, it will increase the surface area of contact of the gap between the gas and the water, so as to minimize the chance of sucking up, because the rise in the water level for a bit already occupies a very large volume of water. Okay, when you compare with delivery tube, because delivery tube we've got a very narrow cross section. Okay, which means that if you want to suck up the same volume of water, the water level for the right hand side will become much higher. So they will have a higher chance of having sucking back. Any questions so far? So this is what I would like to talk.
錢 Sir，
Yes。
即係上次你咪俾我哋睇條片，就有個人做實驗係關於呢個嘅，跟住佢好似插咗支唔知咩落去，我想問下個支重唔重要？
插個支咩落去 ？Now take a look on that. It is very similar to this. It's very similar to this. Indeed, it serves the different purpose. What he just punched in is a drop of water. Okay, it's a drop of water. So the design is a little bit different, but the principle, they are more or less the same. If you take a look on the book, you may find the gas syringe already filled with water. Of course, the water will not be squeezed inside before you do the experiment. So how we start the experiment is by spray that little volume of water, and the reaction will go. Okay, so you do the same thing. You do the same thing by punching in that it is just a hollow tube of water. Okay, hollow tube containing trace amount of water. And what is the first step is the ammonia gas that will meet the water, and they just rapidly dissolve. Because of the solution, the number of moles of gas found inside the round bottom flask, which is much smaller. What is the hidden message? The gas pressure is rapidly dropped. So the similar principle that follows. Okay, is that clear? So this is what you may know about this. And in your past paper, I found that 3 or 4 years ago, there has been an appearance of such experiments. So remember, you need to be highly aware of some experimental setup. They may give you some very authentic experimental design and ask for explanation. And this is one of the examples. Okay, is that clear? Now, so we come to this on the property of alkaline. Okay, on the property of alkaline. So before we start, I would like to draw attention on watching this video, activity 14.3, investigating the properties of dilute solution for alkaline. It may be a long one. Okay, it may be a long one. So please take note of that.
In this experiment, you are going to investigate the effect of dilute solutions of alkalis on indicators, reaction of dilute solutions of alkalis with metal ions, and reaction of ammonium compound with calcium hydroxide. Pour 4 cubic centimeters of dilute sodium hydroxide solution into each of 3 test tubes. Add 2 drops of litmus solution, methyl orange and phenolphthalein to each test tube separately. Record your observations. Litmus solution in dilute sodium hydroxide solution appears as blue. Methyl orange in dilute sodium hydroxide solution appears as yellow. Phenolphthalein in dilute sodium hydroxide solution appears as red. Pour 4 cubic centimeters of dilute aqueous ammonia into each of 3 test tubes. Add 2 drops of litmus solution, methyl orange and phenolphthalein to each test tube separately. Record your observations. Litmus solution in dilute aqueous ammonia appears as blue. Methyl orange in dilute aqueous ammonia appears as yellow. Phenolphthalein in dilute aqueous ammonia appears as red.
Okay, this is the first one. I would like to chop it into several parts because it's a little bit too long. And first of all, it tells you some basic property of alkaline, in which it will turn the color with acid base indicator. So you will write in here the action of alkalines into acid base indicator. So 3 chemicals are mentioned. Okay, 3 chemicals are mentioned. What are those three? Hewitt, what three chemicals I mentioned, and what is the color? 邊三隻啊？
一隻紅色之後，一隻橙色，一隻紫色嘅，我記得。
紅色、橙色、紫色。Some of them they are you may watch it on the color, but if you read it for reality, the color should be yellow, blue, and red. So what is the exit base indicator? 洪志康記唔記得邊三隻啊？
一隻係 phenolphthalein，
跟住咧記唔記得另外嗰兩隻？
嗰個咩 orange，
methyl 甲基橙。第三隻你識㗎啦，呢個由細到大就 Form 2都成日學嘅。我哋用 paper 嘅。
limus
係啦 ，limus 啊。咁我哋咧其實用 limus solution。咁喺實驗室入邊嚟講咧，we've also got limus solution as well. Okay, so it please blue, red, and yellow, which represents the action of alkaline on the base indicator. While the alkaline mentioned is NaOH and also ammonia. So which may find you such conclusion. Limus solution blue, methyl red, phenolphthalein red. Besides, we have got alkali is said to be slippery feel to the skin. So that's why it's not irritating, very strange. Okay, but I've got a bitter taste. So once you touch some alkaline into your hand, and you may find that your finger, okay, your fingertip will become very, very slippery. Okay, and finally wash your hands for a while. Rapidly, you may find your finger is very, very smooth. So smooth that the fingerprints have all been gone. So remember, it is very that type of action on the skin is not so obvious. Okay, so it's quite different from acid. For acid, it sprays to your hands or fingers. The first feel you may find it some itchy feeling. Okay, if itchy feeling. If it's the more concentrated the acid or the more time that you get exposed to the acid, you may find that the feeling will be more intense. Okay, and finally you may get chemical burn. But for using alkaline, that kind of chemical burn is different. Okay, so different that first of all you feel it as slippery only. So, but at the same time, the reaction has already started on alkaline on the finger. Very, very strange. If you taste it, if your chance, it is a bitter taste. Maybe some of you may not have tasted before, right? For lime water, it was once one of the possible chemical to treat the excess of gastric juice inside your stomach. 以前啲人都係㗎，有人用石灰水嘅，and very strange, and it will give you a bitter taste. Besides, they would certain other property, just like conductive electricity, the reaction with certain metal ions to form precipitate and ammonium compounds. That too is our main focus. Okay, these two they are main focus. I would like to show you in the video later. Now, first of all, is our conductor of electricity. Now, you may know that the reaction like this. Okay, so you place the you make a closed circuit with two carbon electrode and put the chemicals, either the two alkaline, NaOH and ammonia inside the water, inside the beaker, and to connect in the light bulb. Finally, the light bulb is on. The reason behind, you may know that is mobile ion, right? Okay, but the question comes, for NaOH, how can we get the ions? For ammonia, how can we get the ions, right? For NaOH, I get the ions is very simple. It's because it's indeed an ionic compound. So once I add water, they will already make the ions mobile. Do you still remember that one? So we will call that the NaOH, the sodium ion hydroxide ion dissociate. Okay, dissociate to form sodium ion and hydroxide ion. Because they are set to be mobile this time, it will help conduct electricity. Okay, how about ammonia? How can ammonia produce how can ammonia conduct electricity? Quite strange, isn't it, right? Ammonia itself is a molecule. How can it conduct electricity? And you say that it is because of mobile ion. How can I change from molecules to ions? How?朱嘉怡, how? You will find it the connection not so ready. You may type in the chat box.點解啊？點解 ammonia molecules 點解會通電啊？最尾
有嗰個mobile ions 係嘛？
係啊，咁啲 mobile ion 咁乜嘢喺 ammonia solution 入邊有啲咩 mobile ion 啊？molecule 就 molecule 啦，就冇 ion 嘅啦。Okay, I can see one student, ammonia gas react water, it become ammonia in aqueous state. During the process, it undergo ionization to create hydroxide. Good. Besides hydroxide, what else can be formed? It's not just hydroxide. Now, you will find it aqueous ammonia, water to form hydroxide. There must be some chemical left behind, right? So what is that? Ammonium ion. Now, both they are also a mobile ion. Okay, but if you want to talk about this one being 1 molar and 1 molar, of course, you use this combination, it will make the light bulb dimmer. DIMM. ER. While you use 1 molar NaOH, the light bulb will is brighter. Okay. Why? It's because of the difference in what? 點解會咁嘅？兩拍嘅。係兩拍嘅。Now, the brightness of light bulb, it is just a reflection of something. Okay, what is that? The concentration of mobile ion. So you read through that 2 equations very carefully. Okay, by means is these 2. Okay, could you please tell me what is the difference in the concentration of mobile ions between the 2? What is the difference? Which one would have a higher concentration of mobile ion?
Sodium hydroxide.
Sodium hydroxide, yes, that's right. Sodium hydroxide. Why? It's because of the dissociation. You write down a just single arrow, which means that the dissociation is a complete one. All of you, please mark it down. It's a complete dissociation. When you compare with this one, we've got a double arrow, which means that the ionization is just incomplete. or we call that a slight ionization. Okay, so we would mention the difference between NaOH and ammonia as a strong alkaline and a weak alkaline. In other words, if you want to talk about the concentration of mobile ion, the X factor I will just mention is about the strength of alkaline, whether or not it is a strong alkaline or not. One more factor. One more factor here. Now you may, I've just written here. I've made a fair test, isn't it, right? How can I make it as a fair test? I put this, what is that? 1M, 1M, what is that? What is 1M? You don't know? What is that? What is mean by 1M?
The concentration.
Yep, concentration of alkaline. So the second factor I would like to draw attention to it is the concentration of alkaline. If you use the higher concentration, alkaline higher concentration, of course, mobile ion concentration is higher, while the light bulb will become brighter. Now remember, you talk about concentration, but not number. Okay, it tells you how the density of the mobile ion inside. Okay, how packed the mobile ion is, but not how much the mobile ion it is. So in order to get to know my understanding between that, which is if I use a larger beaker, okay, if I use a larger beaker, but if the same chemical, the light bulb will not be brighter. Can you get my point? The light bulb will not be brighter if I do so. So it will tell you it is just a matter of concentration, but not volume of the alkaline. Any questions? Any questions? Understand? So remember, concentration is not equal to number or volume. So remember this one. If I enlarge the beaker, I add more chemical to it, the light bulb will not be brighter. Understood? Now, you do the same thing, okay, to relate to exit. How about exit? Exit also conduct electricity, right? You turn the previous page to talk about the property of exit. Take a look on page, yeah, here, page 4. So the conductivity, can you see that? I also highlight it as mobile ion. But this time, the conductivity of the exit, how would you depend on? Again, it is made the concentration of mobile ion. Will affect the electrical conductivity of the exit, which will affect what? The brightness of light bulb. Agree? So, what are the factors that affect the concentration of mobile ion? We have got 3 factors that affect. This time, 3 factors. Sagahin, could you please suggest 1?又揀變咗算啦。
The concentration of acid.
Yes, concentration of acid. Good. The higher concentration of acid, the more concentrated the mobile ions is, so the conductivity of acid will become higher, the bright bulb will be brighter. What else?
Strength of acid.
Strength, right? Strength, yeah. Strength of acid. Yes, the stronger acid, it would have a larger degree of ionization. Okay, you talk about percentage of ionization of exit. Percentage of ionization of exit. So could you please give me some examples of strong exit and weak exit? Anyone who can help? 有冇咩叫強酸弱酸啊？有冇咩例子啊？記唔記得？
硫酸算唔算？
硫酸係啦，硫酸係咩啊
？Sulfuric acid。Sulfuric
acid 咁強酸定弱酸
？Sulfuric acid。OK。
Sulfuric acid 係強酸定弱酸啊？
應該強酸啩？
強酸
係。
OK。強酸仲有冇 HCl 咧
？Hydrochloric acid
都係強酸，有冇弱酸啊？有冇弱酸嘅例子啊？
檸檬酸算唔算？
檸檬酸 ，yes, that's right. Citric acid is a weak acid. What else？ 醋酸咯，都係 weak acid 嚟嘅。咁我點知強弱啊？我就睇下個箭嘴啦。個箭嘴係講單箭嘴定雙箭嘴嘅。咁仲有冇第三個 factor？ 有啊，第三個 factor 有嘅。譬如話呢度有1 molar 嘅 HCl 同1 molar 嘅 sulfuric acid 兩個嚟 ，you do the same reaction and check for the brightness of light bulb. Do they give the same observation? Do they give the same observation? 會唔會㗎？會唔會一樣㗎？啊，梁明章，會唔會一樣啊？
應該唔一樣。
邊個光啲？
係咪睇佢放到幾多 hydrogen 出嚟，即係 H 加出嚟
？Oh yes, you've got the point, right? So this one for sulfuric acid, we have got that is a dibasic acid. Okay, while the hydrochloric acid is a monobasic acid. The difference is the what? Basicity of acid. All of you, please mark it down. Basicity of acid. So, if you want to talk about compare with HCl and H2SO4, both they are strong acid, which means that they have got complete ionization in water to form ions. But you may find these two cases, you may find that for 1 molar HCl, we have got 2 molar of ions. But for this, we have got 3 molar of ions. Now remember, it's not just a hydrogen ion to be taken into the account on the conductivity. An ion also plays a role. Why? They are charged particles. They are mobile. So also they can help conduct electricity. But this time they go into different directions. Okay, positive, negative, negative, back to positive. Okay, if you want to compare that to the this one will have a higher concentration, so they will have a higher conductivity. Can you get my point? So we have got the saying about conductivity, which can help explained by having these 3 factors for acid. For alkaline, just 2. For alkaline, we don't have any concept of basicity. Okay, so you just stick back to the concentration mobile to help to relate. Any questions so far? You got it? Okay. Say something. Now you may capture the screen now. Keep doing. 得未？ But if so, if you're okay, I would just go back to the conductivity of alkaline。就話去到呢度咯，頭先啱啱去到 alkaline 係嘛？嗱，其實都係大同小異嘅啫。嗱，不過冇 strength strength for alkaline 一樣啦 ，concentration alkaline 一樣啦，但係冇 basicity 呢個 concept 嘅。OK， 得唔得 ？Now we come to our core part， 後邊嗰啲咧好金㗎啦，後邊嗰幾個好金啊，所以咧我哋要花少時間睇睇嗰個experiment 啦。
Pour 2 cubic centimeters of aluminium
we
ion
have
solution,
observation.
calcium ion solution, lead 2 ion solution, magnesium ion solution, iron 2 ion solution, iron 3 ion solution, copper 2 ion solution, and zinc ion solution into 8 test tubes separately. Add a few drops of dilute sodium hydroxide solution to the aluminium ion solution. Shake the mixture. Continue adding sodium hydroxide solution until no further observable changes. Repeat the above process by using the other 7 metal ion solutions. Record your observations. In the observations, white precipitate formed in aluminium ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in calcium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in lead 2 ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution. White precipitate formed in magnesium ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Green precipitate formed in iron 2 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Reddish-brown precipitate formed in iron 3 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. Blue precipitate formed in copper 2 ion solution. The precipitate does not dissolve in excess dilute sodium hydroxide solution. White precipitate formed in zinc ion solution. The precipitate dissolves in excess dilute sodium hydroxide solution.
Okay, so we come to this. What is it about? They concentrate the reaction of NaOH with metal ions. We've got lists of the chemicals here. Okay. What is the core part? The core part is that we have got so many precipitate, right, of different colors. Right? Under what situation would it have no PPT? Which solution they will have no PPT when you add upon NaOH? 有啲 metal salt 冇噏到嘅喎。Can we generalize it? 有邊啲咧加咗落去 if you add alkaline to it, no PPT will be formed. There will be no PPT formed. Now, should you please take a look on that? Very similar to what you know in metal relativity series, right? Calcium, magnesium, aluminium, zinc, iron. We've got 2 iron, iron 2, iron 3, lead, copper,係嘛? So you may find something missing, right? For example, silver. Of course, gold, platinum, you need not consider. Why? The metal itself, they are very stable. So you do not have any AQ. But for the first 2, potassium, sodium, okay, you may find there will be no PPT. When you add NaOH to it. Why? Why is that no A? Yeah?
咪因為隻嘢出到嚟係溶喺水度。
Yes, all group 1 salts, they are water soluble. All group 1 salts, they are water soluble. So that's why no matter what alkaline is added, how much alkaline is added, no PPT will be formed, no precipitate will be formed. So you may see the word most metal hydroxide, they are insoluble. There are some exception. The exception is group 1. 例外 exception is group 1. Group 1 hydroxide, they are water soluble. So that's why we use it as a bench alkaline. Okay, NaOH, KOH is used as a bench alkaline. So you add it to different chemicals, okay, you will get different observations. How can we memorize? How can we memorize? Any pattern? Any pattern? No pattern may be found. Any pattern? Oh, easy. Any pattern?
Yes.
Yeah.
Here.
Yes. Any pattern that can you elaborate more?
Maybe some pattern.
Maybe some pattern. Could you please tell me in detail the pattern? How you group them? We have got the 2, right? One is with white color, the other one with they are just with other color. Yeah. Under what situation we got a different color?
Transition metals.
Yeah, it's transition metal ion containing. Okay, it's transition metal ion containing. So you may find these just like iron 2, iron 3, and copper is transition metal. They would give you a colored precipitate. But the color of precipitate, I need to adjust a little bit. For iron 2, it is said to be a dirty green precipitate. Dirty green. This one, the color is more intense, it's darker when you compare with this one and the solution. Originally it's pale green, right? It will turn to dirty green. How about this? The iron 3 solution originally is yellow or brown. It becomes reddish brown. The color of it is very similar to rust, isn't it? While for the iron 2 solution, originally I said it's blue, but once it will form a PPT, it will form a pale blue precipitate, pale blue. So remember the color, dirty green for iron 2 hydroxide, reddish brown for iron 3 hydroxide, and copper 2 hydroxide is pale blue. How about zinc? Zinc is a very special case, okay, because it's just one. It's a very special transition metal in which its ions have no color. Okay, so the PPT form is also a white PPT. Which follows with other chemicals, main group chemicals. No matter it's group 2, group 3, and group 4. So what is the nature of the precipitate? The precipitate is the hydroxide. Can you see that? All those, they are just hydroxide. So it seems like the chemical combination of a few drops of NaOH hydroxide react with that chemical, okay, to form that hydroxide, which is said to be a PPT. So it agrees with the fact that it is water insoluble. Okay. Now, besides, I would like you guys to write a little bit more about the texture of the product. This one is powdery. Mg 2 plus, it is jelly-like, or we'll call it gelatinous, jelly-like. The texture is a little bit different. Aluminium is jelly-like. Lead 2, powdery. Zinc, jelly-like, gelatinous. Iron 2, iron 3, and copper 2. It is also jelly-like, but you may not observe and identify the ions using whether it's jelly-like or powdery for this case, because both either case here they have color. So I usually use the color to help me recognize the identity of those hydroxide. Okay. How about this? However, once I add the excess NaOH, what will happen? Excess NaOH. So some of the precipitates will dissolve. The top two cases, calcium hydroxide, magnesium hydroxide, they will not dissolve. But for aluminum hydroxide, iron lead 2 hydroxide, zinc hydroxide, the precipitate will dissolve to give a colorless solution. While for the another 3 color PPT, these 3, the PPT does not dissolve. Why is it like that? So you take a look on the reaction. Indeed, first of all, if I add a little alkaline, the reaction can be simplified as write down as ionic equation. Hydroxide react with metal ion to form the magnesium hydroxide. So leaving behind, they are just spectator ion. Can you see that? Spectator ion. They are not involved in the chemical change. You do the same thing if you were to talk about the lead. Lead is also like that. So from lead to hydroxide. But once I add little hydroxide, if I change it to in excess, I further add it in excess, they may form a complex log-hapma. With that structure, with the overall charge 2 minus, how you count it? 2 minus. Well, iron 2 is 2 plus, while 1 OH is hydroxide. So altogether, it's just the calculations, a subtraction, addition of all those data. You may find it's 2 minus. The chemical, what we call it, is tetra hydroxyl plumbate 2 ion. Tetra means 3,4. Hydroxyl means hydroxide. Plumbate means lead 2 ion containing, but it is a type of N ion. N ion. So you call it ATE, negative charge. It's not something new when you talk about a hexacyanothirty. The rust indicator, just remember. So we will say that hexa, cyano, thirate, 3, iron. So you do the naming system very similar because it's negative charge, ferrate, it follows with the name of the symbols of Fe, Latin word, ferrate. Hexa means 6, cyano means cyanide. Okay, so very special naming system. So you need to memorize by heart for the other two cases, just like pumpate, sinkate, excuse me, aluminate. You may have also another name to represent, we call it aluminate, plumbate, and sinkate. Okay, with the structure of this complex very similar to plumbate. Can you see that? With that structure, a tetrahedral structure with a tetrahedral shape. Okay, with a tetrahedral shape, tetrahedral. Okay, mathematics, right? So please remember by heart for that 3 cases. Any questions?
阿 Sir 睇下嗰個 shape 嗰度咧，點解有個係 HO 嘅？點解佢唔係 OH 嘅？
Now take a look on the conductivity of the bond. First of all, what is an arrow? What is the arrow? The arrow means what? What is mean by arrow? What is that bond?
嗰個 metallic bond。
Metallic bond? No.
Covalent bond.
Oh, covalent.
Covalent bond. What type of very special type of covalent bond? What is that?
Giant covalent.
Giant covalent, no.
Dative covalent.
Yes, dative covalent bond. 唔記得晒你哋。Dative covalent bond. So indeed, it is a dative covalent bond. Okay, because of dative covalent bond, the arrow pointing towards the electron division center. So this one should be electron rich. Okay, so O should be pointing towards the PP ion, PP2 ions, because the O will have lone pair electrons. So it is electron rich. Okay, but not for hydrogen. So you will write down this part. I intentionally draw like this in order to show the bonding is from the lone pair electrons of the oxygen atom to the central metal ion. So you may see that whenever I write down the O here, there should be the O here to connect that PP2 plus. But not OHO and OOH. It's not a matter of OH or OH. It's a matter of O connect to PP2 plus. Okay? Is that clear?
即係 O 永遠黐住嗰個位。
係啊 ，why? O atom contains what?
O atom你講個 electron rich 喎。
Yes, it's electron rich. Why? It's because of the presence of lone pair electrons. It has lone pair electrons. Okay? So this is what we talked about this part. Any questions? Now, so how about silver ion? Silver ion, they would have a few drops of NaOH added to form a gray or brown PPT. So the chemical is very special. there is no silver hydroxide in nature. Instead, we have got silver oxide. Further addition of the NaOH will not dissolve the PPT. Okay. So the equation for this is very special. All of you, please write it down here. Silver ion reacts with what? If hydroxide to form silver oxide and water. Okay. Please take note of the solid here, right, for Ag2O. All right, questions? Now, why you say that? But remember, but not gold, but not platinum. Huh? Now, before we end up the lecture today, I would like to find this one. It is another one. Okay, with the reaction between the dilute aqueous ammonia solution with metal ions, they are more or less similar. They are more or less similar. Can you see that? They are more or less similar. But one chemical is missing. What is that? Check this page with the previous page. We don't have any calcium ion, right? Why? Indeed, calcium ion will not form PPT. It's because of the dilute aqueous ammonia. The concentration inside that is very low. So there are still some calcium hydroxide, but it is slightly soluble in water. So leaving behind a hidden message is that the calcium hydroxide is not oversaturated to form precipitate. So calcium hydroxide, if I add ammonia to it, no PPT will be formed because the hydroxide ion concentration is too low. Why? Why is it low concentration? It is a weak alkaline. Okay. But wait a minute, Mr. Chin. Why will you add ammonia and the reaction becomes hydroxide? Why? Ammonia dissolve in water. What will happen? They will ionize to form hydroxide and ammonium ion. And so this is the reaction, the chemical species, which will react with the ions here to form the PPT. Now, so as these two cases, remember, these two cases also show no PPT. As said before, all group 1 compound is water soluble. So that's why they are very similar. So once I write down the ionic equations, you do the same thing. That is exactly the same chemical equation as I added as NaOH. But you remember to add this equation as well before you write it down. Otherwise, we do not the markers will not understand how come you suddenly come up with hydroxide. So ammonia dissolve in water to form ammonia ionized, in water to form ammonium ion and hydroxide ion. And start from this and you write down the ionic equation as usual. Okay, is that clear? What else? Something nasty. If you intentionally mention it, which means that this column, it is different, it's quite different from NaOH. Can you see that? It's different. How different it is? Could you please spot for me what is the difference? What do you mean? This個啦，呢個啦，
個 O 啊，
咩 O 啊？
哦，即係冇嘢冇估錯啦咁冇嘢。
咩 O 啊？嗱，for lead iron for aluminium hydroxide or also lead 2 hydroxide. Once I add excess NaOH, the PPT will dissolve. Okay, but for this case, if we will add ammonia to it, not dissolve. For zinc, it's still dissolved, but the chemical is different. I would like to mention it later. The deep blue solution is later. The chemical nature is different. Okay, copper hydroxide, the PPT will not dissolve in excess NaOH, but for ammonia, it dissolves. So you focus on these two cases. Why? It's because of the complex formation. So you may see the two equations here and here. So the chemical, what we call it as tetramine, zinc, and tetramine copper 2. What's mean by amine? A-M-M-I-N-E. It comes from the word ammonia. So ammonia, the nitrogen, will be surrounding copper 2 ion to form a complex. Okay, and similar, I change this part and I mark it as zinc. Very similar. Okay, it's also the same. But the question is that the observation is different. The observation is different. For copper 2, tetramine copper 2 ion in the solution, it forms a deep blue solution. But for this one, it is just a colorless complex. So the chemical to be involved is with the help of ammonia. And while that two equation, it is somewhat new to you. Okay? Is that clear? Now, in order to let you better understand the whole concept, I would like to call upon a afternoon section with you. Aside from this week, usually when we have it, is it Wednesday? Wednesday. Is it Wednesday or today? I forgot. Please check for me. In general, we have got that section, right? I would like to use that section. Let me see. Wednesday, tomorrow, right? Tomorrow, can we see each other tomorrow after your lunch? Okay. At 1:35, you'll have your lesson ended, right? So you have got a 1 hour break and see you guys at 2:45. Tomorrow can manage? Can you manage to have it from 2:45 to about 4? Because next week we will pass the time to our student teacher. I would like to finish that topic. For those who have difficulty to come, could you please let me know by PM. Now, before you leave, could you please let me know your difficult part about today's lecture? We focus on property of alkaline. It conducts electricity, slippery field, is bitter, and it causes a reaction between the NaOH or ammonia to metal ion to form precipitate. So we only mention this, and of course we have spent some time on telling the fountain experiment, right? Yes, complex ion a little bit difficult. Yes, I agree. For the others, could you please type your level of understanding from 0 to 10 in the chat box? Because you will have a break soon. Thank you. Just let me know on that level of understanding. Yep. Yes, a little bit difficult. Okay, shall we meet tomorrow? Okay, after lunch. Okay, we will continue tomorrow in the afternoon. See you. Bye bye.
Bye bye.
Bye bye. Bye bye.
Bye bye.
Bye.
À,
Bye
đúng rồi.
bye.
Bye bye.